Phase diagrams. These are a diagram illustrating how the phases of a substance are influenced by changes in temperature and pressure. It indicates the conditions under which a particular phase is stable. Alright, so what does it look like? Okay, I'll have pressure on the y-axis, temperature on the x-axis. We have lines here, and so I'm going to have a line, a point there, a line coming here, and a line coming there to a point. I'm going to have phases. Solid will be over here. Liquid and gas or vapor. Alright, now there's the 2 points. There's this point, and there's, well, let's use yellow there, we'll use green. Yeah, this one. And this one. Those are the 2 points. Alright, so let's talk about this. There's the areas. In the area, these are the conditions under which only one phase can exist. It's stable. So this area here is where the solids are, liquids are, gas are. Alright, those are the stable phases. Alright. Okay, if I have a line, let's draw a pink line here. Let's just say that is 1 atmosphere. Right? That would be your normal melting point and our normal boiling point, right? Because they come straight down right there, and right, those are those temperatures and that pressure, right? So at, let's say right there is 25 degrees Celsius. Right there, it's normally a liquid at 1 atmosphere. But we can change the pressure and temperature and change the phases. The lines. The lines, this is where there are 2 phases in equilibrium. Alright. So that means on anywhere in this line, like right here, the melting point, it could be a liquid, could be a solid. That's fine. It's an equilibrium. It can be either one. There is 2 points. There's the first point that is highlighted yellow. It has 3 lines connected to it, which is the triple point. This is where, right, 3 phases exist in equilibrium. Right, so all 3 phases can exist there. A lot of substances have a triple point. Some have more than 1 triple point. Some don't have a triple point. And that's okay. Alright, And then finally this point up here, all right, that point up there, highlighted in this highlighter color right here, like this purplish, pinkish color, would be the critical point. And this is where we have a super critical fluid. Right? You cannot distinguish between the liquid and gas states. So, what does that mean? It means if you have like a water bottle and you have, you can see into the water bottle, you can see the line, the meniscus, where the liquid is, and air starts and stops, and the water starts and stops, or ends. Well, when we get a lot of temperature and a lot of pressure, the vapor and the liquid basically become a fluid, and you can't tell the gas and the liquid apart anymore. It's kind of neat. Alright? It's kind of neat. So let's look at some triple points, or some phase diagrams. Here's 3 of them. Alright? So there's a couple things that I want to show you. Alright, so the critical point of water, just so we know, this point right here, right, above there, and it kind of goes this way, right, up in this region, this critical point and that critical fluid, that happens to be at 218 atmospheres and 374 degrees Celsius. Okay, not a lot. The triple point here, this happens to be 4.58 torr, which is very small, and 0.01 degrees Celsius, which is also cold. And if you notice, you got carbon dioxide has a positive slope of this line. Iodine has a much bigger positive slope. Water has a negative slope. Alright? So the melting point line has negative slope. Alright? It's unusual. Slopes left. This is due to hydrogen bonding, which means that the solid is less dense than the liquid, which means, of course, ice floats. Alright? That's kind of neat. Alright, and so those are the temperatures, and that's how. And so my goal for this is, alright, if I tell you that you're at 800 torr and negative 25 degrees Celsius, where are we going to be in water? Well, there's 800 torr is going to be up here, negative 25 will be down here, so you're going to be in a solid. That's what I'd want to know. Right? I don't expect you to be able to look at a curve and, oh, that's water. Oh, that's iodine. That's sulfur. That's carbon dioxide. We don't expect that. I want you to be able to tell you, right, we can look at this. Look at carbon dioxide over here. I got 1 atmosphere is down here. So 31 degrees Celsius is there, negative 50. So carbon dioxide is a gas. You can liquefy it, right? If you're, let's say, 25 degrees Celsius and you're up, look at that. You pressurize it, it can be a liquid. Right? If you cool it down, pretty cold, right, it becomes a solid. It does freeze. That's kind of fun. Alright? Iodine. Iodine likes to, if you look at the temperature here, iodine likes to actually sublime, go from a solid to a liquid, to a gas, because there's 1 atmosphere, and it likes to go. It just sublimes because it doesn't stay in the liquid very much. All right, and so now those are the phase diagrams, and that's basically all I want you to be able to tell me. So if I tell you, all right, iodine, you're at 5 atmospheres and I don't know, 300 degrees Celsius. Where are we at? Oh, 5 atmospheres, 300 is probably in here. It's probably a liquid, right? Could be a gas. Like, so it'll be very close. It'll be, you know, here or here or here or here or here or here. It'll be a close spot. Or I'll have you, which points? Where's the critical point? Where's the triple point? Where's the solid at? Right. Those are the types of things I'd ask you for that. All right. So that's the phase diagrams. Um,